4.4, number 17, this function here. First thing we notice about this function is that we look at the brackets on the furthest outside, that's squared. So think of what's inside here as x. And we know that the derivative of x squared is 2x times the derivative of x. And so we perform that derivative first. So we get 2, and then what's inside, 2 minus, this is w squared plus 1, times the derivative of everything that's inside. Okay. So this is the same, and we need to calculate the derivative of this. Well, we know that the adding some constant, it just gets killed when we take the derivative, because the derivative of some constant like 1 is just 0. And so the derivative of this, we do the same rule again. So we get 2 times what's inside, 3, 1 minus w, times the derivative of that. Okay, so let's just group the 2's. So you have 4 out here, times 2 minus 3, 1 minus w squared plus 1, times 2 minus 3, 1 minus w. And now we need to investigate what the derivative of this part is. So this is like chain rule twice now. And we know the derivative of some constant is just 0, so we don't care about that. And you can write this part as 3, 1 minus w to the negative 1, and that's negative. So the derivative of this is another chain rule, yet again. The 1 gets brought outside to make that positive, and then you subtract 1 from it. And then the derivative of 1 minus w is negative again, so it makes it negative. So what the derivative of this part is negative 3 is negative 1 over 3 over 1 minus w squared. And then you could simplify this a bit if you want, but that's basically the derivative. And the trick here was that you need to use chain rule 3 times, and writing 3 1 minus w as just 3 1 minus w to the negative 1, and then just using the exponent rule is a way to simplify matters. Now we are going to do 4.4, number 19. H of x is equal to 2 to the exponent of x times 3 to the exponent of x. And just by exponent rules, we know that this is 2 times 3 to the x, because exponents distribute over multiplication, which is equal to 6 to the x. So the best way to go about this is that we know that e to the ln of x is equal to x. So 6x, we can use this. We can plug 6x into here, and we have that e to the ln of 6 to the x is equal to 6 to the x. So furthermore, this is equal to e to the x ln 6. So we replace this with e to the x ln 6. So when we're looking for what if we're looking for what the derivative of h of x is, then that's going to be the derivative of e to the x ln 6, and the derivative of that is by chain rule. We know that that E keeps everything the same, but then we need to by chain rule we need to derive what's inside. So the derivative of x times ln 6 is just ln is just some constant times x. We drop the x, and we know that this from over here is just equal to 6x, 6 to the power of x. So we have 6 to the power x times ln 6, and that is the derivative. One more chain rule example, and then I'm going to do one implicit differentiation. So this is 4.4, number 23. F of x is equal to ln of x4 plus ln 4 of x. So let's rewrite this in a way that makes it more clear, the order of operations. Alright, so if we're going to derive this, we know that the derivative of a sum is the sum of the derivatives. So that's ln x4 derivative plus ln of x to the exponent 4 derivative. And we use the chain rule in both cases. For this one, the derivative of ln is 1 over whatever's inside times the derivative of what's inside. For here, this is x to the 4. So the 4 gets brought out front, ln x to the 3 times the derivative of what's inside. And the derivative of ln x is, of course, 1 over x. So the derivative of x to the 4 is 4x to the 3. So we have 4x to the 3 over x to the 4 plus 4 ln x3 over x. Of course, we can do some cancellation. 4 over x can be pulled out, so we just have 1 plus ln x to the 3. And that is our answer. Finally, 4.4, number 53, we're going to derive using implicit differentiation to isolate y prime. So we're given this equation, and the first thing we do is we differentiate both sides using the product rule. On the left side, we get y prime ex plus y ex, and this is because we derive the first times the second plus the first times the derivative of the second, and the derivative of e to the x is just itself, and the derivative of y is y prime. And then on the right side, the derivative of x is 1, so we're given ey plus x times the derivative of ey, which is itself, times the derivative of what's inside, which is y prime. We rearrange so that y prime is on one side. X e y, y prime, ey minus y ex. And then we're just moving this one over here and moving that one over there. And then we pull the y prime out. So we have e to the x minus x e to the y is equal to e to the y minus y e to the x. And then our answer is simply we divide by what's here, which isolates our y prime, and that is our answer. I'll write it out nicely.